Probably what would be more beneficial than even just explaining through the examples with you, or the properties with you, is doing some examples. So I've got several examples that I'm going to do with you. I went through Delta Math and picked out some that look like what you would see in your homework. So I would advise you not to skip through any of these videos on examples and watch. So here is example 1. U to the 4th power times u to the negative 2, all to the 5/2 power. Now, there are lots of properties you can apply here. So you don't necessarily have to do any of these problems the same way that I work the problem. Well, we should get the same answer either way. So probably what I would do on this problem is I would start by putting these together. So I would make this u to the 4th over u squared, because a negative exponent means it moves to the denominator. So then I would have that to the 5/2 power. Then I would simplify what's inside here. So I would get u squared to the 5/2 power. Now I notice that I have a fraction exponent. I have a power to a power. So the way that you take care of that is by multiplying. And remember, this is over 1. So I have 10 over 2, which is u to the 5th power. Again, you didn't have to do it that way. Maybe you applied the power to each of these first and then combined them. So we don't have to do them the same way, but we should come up with the same answer. Here's the second example. Z over z to the negative 6, all to the 1 over 28th power. So again, I would probably choose to work this one by simplifying inside the parenthesis first. You don't have to, but I would say, since this is a negative exponent in the denominator, I'm going to move it to the numerator and add it to the one that's already there. So now I would have z to the 7th power to the 1 over 28th power. And now I have a power to a power, so I'm going to multiply. And so I could multiply straight across and then reduce, but what I notice is that 7 and 28 reduces to 4. So my answer would be z to the 1/4 power. Another way that you might see this, if it's a multiple choice, this would be equivalent to the 4th root of z. So it all depends on how they ask you to leave your answer. Both would be correct. Here's the third example. 8 to the 3/4 power. So I want to try to simplify this one. So the first thing I'm going to do is turn it into radical form. So I have the 4th root of 8, and then I can put the 3 on the outside or put the 3 on the inside. It doesn't matter which one. But what I'm going to do is first see if I can take the 4th root of 8. Well, I'm going to break down 8 into, I know that 8 is 2 times 2 times 2, and I have that thing 3 times. You may be able to do this in your head, and that's fine. I just want to make sure that everybody can do it some way. So since it's a 4th root, I'm looking for things in groups of 4. So I have a group of 4 2's, so that puts a 2 on the outside. I have another group of 4 2's, so that puts another 2 on the outside. So now on the outside, I have 2 times 2, which is 4, and all that's left on the inside is 1 2. So I have 4 4th roots of 2. Notice this 4 is a coefficient, so it's bigger than the little index number there that makes it the 4th root. Let's do another one like that one. Here's the 4th example. 28 to the 1/2 power. So what I'm really looking at here is the square root of 28. So I want to try to think of things that happen in groups of 2. So 28 is 2 times 14, and 14 is 2 times 7. So I have a group of 2 2's, so that puts a 2 on the outside and leaves a 7 on the inside. You could write this as 2 times 7 to the 1/2 power. The 1/2 would only go with the 7 because it's the only thing that's square rooted. But more than likely, you'll leave your answer just like this. Here's the 5th example. So we're going to kind of ramp it up here a little bit. 8x to the negative 15, y to the negative 21, to the negative 5/3 power. There's a lot of ways you can start this one. Some people may choose to go ahead and cube root this and make it to the negative 5 power. Some people may choose to go ahead and try to simplify each one of these. What I would probably do on this one is, since I noticed that there's a 3 here, and that means cube root, and 8 actually has a cube root, I'm probably going to turn this into a problem where I can just take the cube root of everything. So I'm going to do 8 to the negative 5/3 power. Actually, I'm going to go ahead and get rid of this negative. No, I'll do this. 8 to the negative 5/3 power, and x to the negative 15 times negative 5/3 power, and y negative 21 negative 5/3 power. So I just applied the power to each term. And I kind of go back and forth in my head trying to decide which way you would start working it and which way would be the simplest. So I'll probably just do these a whole bunch of different ways. And again, you can do it however you want as long as we get the same answer. So here I notice this will be 1 over 8 to the 5/3 power. Here I have a power to a power, so that means I'm going to multiply. So I'm going to put that over 1, and then I'm going to see if anything simplifies, and it does. 15 and 3 goes to 5. So I have negative 5 times negative 5, which is x to the 25. And since the negative times the negative turned to positive, that's in the numerator. Okay, same thing's going to happen here. I have something in the numerator that simplifies with something in the denominator. 3 goes into 21 7 times. So I have negative 7 times negative 5, which is positive 35. So now I'm gonna go ahead and combine here. So I have x to the 25, y to the 35, all over. And then I know that 8 actually has a cube root, so I'm going to write it in this form. And the 5 can go here or here. I'm going to write it like this because I know that the cube root of 8 is 2. So I have x to the 25, y to the 35, over 2 to the 5th. And I know that 2 to the 5th is 32. So my answer would be x to the 25, y to the 35, all over 32. Let's do one more example on this video, and then we'll take a small break here and go on with the next examples. So here's the 6th example. 16 x to the 32nd power, y to the negative 4th power, to the 3/4 power. So again, you can work this however you want. I'm going to apply the 3/4 power to each thing. So I'm going to have 16 to the 3/4, x to the 32 to the 3/4, y to the negative 4th to the 3/4. Notice how I write my fraction, my number, when I write it next to a fraction. I like to write it up top with the numerator so it'll cancel. So this one's nice because this turns into the 4th root of 16 to the 3rd power. And the 4th root of 16 is 2, so this is 2 to the 3rd power, which is 8. So that part turned into 8. Let's see what happens with the next part. I have a power and a power, so I'm going to multiply. And I know that 4 goes into 32 8 times. And then multiply straight across, so this is going to be x to the 24th. And then here, the 4 in the numerator and the 4 in the denominator cancel. So that would be y to the negative 3. So if the directions say write your answer in positive exponents, my answer is going to be 8 x to the 24, and then I'm going to move the y to the bottom and make it positive 3 so it has a positive exponent.